Good afternoon, everyone. My name is Christina, and we're pleased to welcome you to the Washington Labs Academy webinar series. We hope you find the next hour or so useful and informative. We've developed our webinar series to deal with some of the technical and administrative issues our customers face on a day-to-day basis. We recognize that engineering challenges can be complex, and we're always looking for ways to support the technology industry, which underscores the purpose of today's webinar. As one of the hottest topics in the tech industry today, drones are used for surveying, photography, law enforcement, sightseeing for hobbyists, and a variety of military applications. Drones are being enhanced for quality and capabilities with the goal of evolving into full autonomy. And the need to review requirements for unmanned flight, for EMC, for environmental, and for safety compliance is becoming a fact of life for many manufacturers. Further, legal implications and many restrictions are now in place due to concerns for privacy, endangerment of commercial aviation, and to include the possible use of drones for nefarious purposes. These are subjects that weigh heavily on the minds of both users and manufacturers alike. So this webinar came together with the intention of providing folks with basic information and to touch on some of the things that manufacturers should consider as part of their testing solutions that would help them to go to market with a greater sense of safety, to prevent personal injury or property loss, and to promote public safety. But before we get into our discussions, I'm going to go over a few housekeeping details. Estimate the main bulk of the menu on your screen, go to View, and then select Full Screen. Hit the Escape key, and you will return to normal view. And we'd like to hear from you with any questions or comments about any of the material we cover in today's webinar. You can contact us via phone or email. You can see our contact information here. Please reach out to academy@wll.com or to the presenters directly. And now I'd like to introduce our speakers. Stephen Koster, President, Washington Laboratories Limited. Steve has over 30 years experience in testing systems and devices for regulatory compliance. His expertise spans a full range of product evaluations from IT, medical, machinery, measuring, and communications, including wireless. He heads the Washington Laboratory team, accomplishing all manner of product compliance evaluations. Programming note at this time, Steve Koster is attending TCD training in Baltimore, so we have Steve Ferguson presenting on his behalf. Elmer Rodriguez, Product Safety, Environmental Services Manager at Washington Laboratories Limited. Elmer has an electrical engineering degree and has been working in the communication, RF, and electrical industry for over 15 years. Elmer started his career with the U.S. Army and worked with the implementation of in-vehicle wireless routers and GPS tracking as part of Army Digital Soldier Program. After leaving the Army, Elmer worked for several paging companies in the greater DC metro area in the area of system integration, monitoring, and maintenance that also included reverse engineering. Elmer joined the Washington Labs team in 2007 and has been involved in the EMC, EMI, environmental, and safety testing since. During his spare time, Elmer volunteers at his daughter's school as a judge for the Future Engineering Team program, on which he judges several robotic and use of technology to improve our lives competitions. Sam Violette is a compliance testing engineer for Washington Labs Limited in Gaithersburg and Frederick, Maryland. He tests for product safety and performance as well as electromagnetic interference. He also has an extensive background in mechanical engineering and manufacturing processes with a keen application for international standards. Corey Blackford is a senior compliance technician for Washington Labs Limited in Frederick, Maryland. Corey has a broad background in engineering and design, with initial experience in shipping logistics and custom home construction. He originally started his foray into engineering with civil drafting and design, working on numerous residential and commercial projects, often coordinating between drafting, engineering, and government groups. Following the housing crisis, he moved into structural drafting and design of cooling towers, which was involved in several large-scale coal and nuclear power plant projects, as well as a variety of smaller retrofit-in-place commercial tower designs and new product research and development. Joining Washington Labs in 2010, he has worked in environmental and product safety testing since then, overseeing product testing from the initial quoting to the final reporting stage. Outside of work, Corey is an unrestrained bibliophile with a collection of books often mistaken for a misplaced public library. So without further ado, let's get started. Unfortunately, as I said, Mr. Steve Koster is unable to join us, so we have Mr. Steve Ferguson, who is going to present on his behalf. Hi, Steve.
Well, good afternoon. Thanks, Christina. I want to add something to that introduction you did for Sam. I understand that earlier this week he took the FAA exam for unmanned vehicle and air vehicle and passed. So congratulations, Sam.
Yep, congratulations.
Steve Koster put this together regarding the radio general requirements, and then he realized that he had a duplication problem here. So I'm going to kind of go through as best I can. Hopefully, there's not a lot of questions on this, so but Steve will answer them in the future when we get to that. An integral part to the whole radio thing is the radio link, somewhere between the controller that's being operated by the operator as a handheld device to the systems that onboard the vehicle that provide all of the commands and et cetera to maneuver this thing. So the radio link is a part of it. Now, many drone manufacturers incorporate a radio link with an existing modular approval. So they're not trying to design a radio system, they're trying to incorporate something that's there, and this modular approval comes about as the way to go. They also realize that in order to incorporate that, they have some labeling issues and things like that where they have to identify what FCC identification number may be incorporated. As Steve passed on that yesterday at the certification training that he's attending, the FCC hosted a panel discussion regarding the modular approvals and integration. So you might need to keep aware that the discussions may prompt some changes. It should definitely prompt some updated KDB or knowledge database guidance to ensure consistent tests and evaluations for all the facilities. It seems as though the guidance that existed wasn't always there. So in thinking that way, the digital system with a module has to be dealt with. Now, the digital system may need some sort of approval for an FCC for a non-transmitting or an unintentional radiator. So we're looking at that, so we need to test it up to 5 times the highest frequency of the device. Well, sometimes these digital devices were approved and they have very low data speeds, so they don't test above a gigahertz or some low frequency like that. But if a Wi-Fi module, for an example, is incorporated, the 2.4 gigahertz radio frequency is introduced into the whole system. So therefore, the digital testing would then need to go up to 12.5 gigahertz, even if the rest of the circuitry operates at a much lower clock speed. This is not unusual, but this particular type approach is not very thorough throughout the industry, and the FCC has made this an issue. I know that was part of the discussion by Steve's things. Remember, the approved standards have to be dealt with. The use of the Wi-Fi communications is the most typical, with FCC Part 15.247 applicable for the U.S., the RSS 247 applicable to Canada, and it's the ISCD, formerly the Industry Canada Group. That tends to be very harmonized with the U.S. 15247. The European Union falls under the Radio Equipment Directive, and typically for these, the ETSI EN 300-328 is applicable if it is a Wi-Fi type module. However, if you use a wireless link other than the Wi-Fi, verify that the correct rule parts or standards have been used for your approval. You incorporate all those things. So, in the bottom line is, don't omit the radio approval as an integral part of your device approval. You need to make sure it's there, or you could see an issue with getting a permit to operate. Be sure to adopt the correct standard. Like I say, Wi-Fi is typical, but other things are available. And remember that the requirements include the maximum permissible exposure, especially for the handheld portion of that thing, unintentional emissions compliance, and appropriate labeling and user instructions. I know Steve can easily give you direct guidance on this, so don't hesitate to reach out to stevek@wol.com. And I believe, yeah, there's his information. With that, I'll turn it over to the next speaker, Christina.
Yep. Thanks.
I give the ball. You'll take care of moving that.
Yep.
Thank you.
Thanks, Steve. So we're going to go ahead and shift the conversation now toward drones and safety compliance, presented by Mr. Elmer Rodriguez. Elmer, how are you today? Hopefully, Elmer can hear me.
Can you hear me?
There you are. Hi, Elmer.
Hi, can you hear me?
Yes, we got you.
Awesome. Thank you, Christina, and good afternoon, and welcome to everybody that is taking some time to actually attend this webinar. Once again, my name is Elmer Rodriguez. I am the Product Safety Environmental Services for Washington Laboratories. And today, my main objective is to give you a presentation to offer you the basic safety overview to help you design the test suite that, if taken into consideration early into the development of your product, it should help you alleviate some of the common headaches when the day comes to get your drone tested for compliance. As you may, excuse me, as you might expect, it's not only a question of if drones will affect your life, but rather when and how. Whether drones a cheap unit found at your local toy store or one costing thousands of dollars, a dramatic increase in the usage is on the rise. It has been reported that since 2015 to 2020, the market for commercial and civil applications of use of drones will grow at a compound annual growth rates of about 19%. So there are a lot of opportunities to get exciting new models into the market, and likewise, there are many exciting new ways to get into trouble if you don't take the safety requirements and safety considerations into account. As a result of the increase in drone usage, the number of accidents and the close calls is also increasing. There's a valid concern from users, government agencies, and the general public for building a safety protocol, oversight, and regulation. The next slides will go over some of the items that you should keep in mind while designing your testing program. Keep in mind that this is not a complete list, but rather some of the issues we have seen while evaluating some of our clients' recent products. So you have decided to build a flying box. How do you know if your product will be safe? Will it perform as designed? Here's seven of the things that you might want to keep in mind while designing your next drone. Functional testing, electric safety test, performance, batteries, software, packaging, and toys and children products. Depending on the type of device that you design, whether it's going to be under 1 pound or all the way to 55 pounds, some of the requirements change by the definitions. So let's take a look at the functional testing. We have to check for the proper safety operation of the drone. And some of the things that we have to take a look at are safe start, flight stabilization, the GPS fail-safe, and other key operations for your device. So what happens when we actually hit the go button? Things that we have to consider from the safety point of view, we have to look at the propellers. Will the propellers fly off and result in personal injury? What happens if the unit takes flight when unintended? Now, will the unit take off and actually hit somebody or end up producing damage to property? Flight stabilization. Will the drone fly erratically? What happens if they cannot control it as it loses stabilization? What is the potential for injury to personal and damaged property? Also, when we look at the GPS from the safety point of view, what happens if the drone loses its GPS? Do we have some type of measure or any type of safeguard where the unit will return to its home, or will the unit continue to fly erratically until it loses powers and then falls down to the earth? The electrical safety was one of the major things that we have to do when we actually test the drones for compliance. General product safety requirements to apply, and also you have to keep in mind the different directives that are in play, the rate directive and the low voltage directive too. And that also includes any specific standard that might apply to your device, as the robot or the drone has a radio device in it. It also has the potential that a camera is going to be part of the device. Then different applications and different standards are required. So from the safety validation of the critical components, something that we have to keep in mind are the wiring, spacing, temperature, moving parts, marking, and documentations, and also risk assessment and risk analysis for your particular product. Performance. Although not quite safety related, certain expectations should be considered as to offer a better product. You should ask yourself, will my product meet a positive experience, and what to consider? Usability. How easy it is the unit to operate? How about how the learnability? How easy it is to learn the proper operation of the drone? Functionality. Is the unit going to serve its purpose well? Durability. How long can you guarantee your product? Do you know how long it will last, or should it last? Vibration and shock. Do I know how my product will fare with constant vibration and the many drops during its life cycle? What are the safety implications that you have to take into consideration as the unit gets exposed to this type of vibration and shock? The next thing that we have to consider is typically batteries. What can I say about batteries? The batteries that has not been said lately. We have seen it on TV, the news media, how the Boeing have many problems while developing their newest aircraft. And we all remember the sensor phones that were taken off the market in recent past as the batteries were exploding. Something that you have to consider well when coming to the safety department to do a full evaluation, as your product will have, most likely will operate from a battery pack of some sort. Software. This is a major one. Even though a lot of the safety evaluations are not, we don't really look at the software that close. This is actually designed for a different department. But something that we have to consider is that how reliable is the code that you have written? Will the code run the way that it's intended? Will you be able to control your device at all times? Also, any accessories that you might want to implement into your drone. As everybody knows, everybody is looking at the potential of using drones to deliver packaging and delivering any other goods. Will the software malfunction and resulting on the drones of losing its payload and possibly injuring somebody as it falls? Reliability. Potential for cybersecurity. Will anybody be able to hack into your device and take control over the drone while it's in flight? What are the potential shortcomings? Remember, you are liable for your product. Packaging. So you spend months designing, testing, marketing, and shining your drone, and you are finally ready to deliver it to your clients. Will the packaging provide enough protection to ensure your drone will survive the trip from the warehouse to its final destination? What is the best profile for vibration in packaging? How is your device going to be shipped? Is it going to be shipped via air, FedEx, UPS? All of those things will probably have a negative impact on your device. How many boxes can I stack before the packaging fails? What about the environmental conditions of your transport, and how will it impact my product? Any other potentials that you have to take into consideration when you're looking at packaging? Proper design, proper testing is recommended. Toys and children. This is something that is very important because not every drone that is being designed in the market is for commercial use or for military use. There are many drones that are actually being designed as a toy. And so we have to protect the children. As everybody knows, children have the tendency to put everything in their mouth. So we have to look at the chemicals being used as part of the plastics and everything else in it. So this also we have to look at design reviews and evaluation. We have to look at the flammability testing, mechanical and physical testing, and checking hazards. What are the potentials for cuts and everything else that might injure a child? and any other implications that we have to consider as far as shielding scope. In conclusion, I hope I was able to provide with a basic roadmap to some of the safety evaluations requirements from drones. But the most important things to take into account is that you need to work with your test houses to develop an adequate test program that will help you go to the market and deliver a safe product to the end consumer. Also, understand your market requirements for product safety. Once again, you have to look at the requirements on the country-by-country basis. Also, understand your safety concerns beyond the electrical safety requirements. We're looking at moving parts. We're looking at the potential of objects falling from the sky, and also the legal requirements that we have to keep as far as following the FAA requirements and the law. And with that, I hope I was able to provide you, like I say, with the basic requirements for safety and how to put a test plan prior to coming to your test house. I would also like to say thank you very much for your attention, and feel safe.
Thanks, Omer. I tell you, people fly drones in the darndest places, just like hobbyists. My husband and I were at the shopping center the other day and saw a drone flying over a capacitive bank on a high voltage line. I was like, oh man. So there's safety in a nutshell right there. And yeah, and flight, actually, these people need to know how to control their drones. So with that, we'll move our focus on to the UAS piloting, and here to discuss the FAA regulations and requirements, we have Mr. Sam Violette. Hi, Sam.
Hi, Christina. Thank you very much. How are you doing?
Doing good, you?
Good. Doing great. So I'm here to talk about the FAA's Title 14 Code of Federal Regulations, Part 107. If you want to fly more than a hobbyist and you want to get paid for possibly aerial photography or flying anything around and flying anything that's under 55 pounds, you're going to have to go ahead and take this unmanned aircraft general exam. The exam is 60 questions and 120 minutes is what you're allowed to take the exam. So I'm just going to briefly discuss a couple different things from the different aspects of Part 107. Some general requirements, the application process, quickly go over the exam topics, exam locations, registration, and different kind of applications. So you're going to want to give yourself approximately about a month to study and go over the study guide before taking this exam. Some of the general requirements are English fluency, U.S. government issued ID, must be at least 16 years old, good physical and mental condition, pass the initial aeronautical exam at the FAA approved knowledge testing center, and that cert is valid for about 2 years. Then you also have to file a 8071B form after taking the exam. So here are just some basic topics that were on the exam. Applicable regulations, airspace classifications, operating requirements, flight restrictions, aviation weather sources, and the performance factors of different weather, small unmanned aircraft loading. And basically what that is if you're taking a turn at 30 degrees, you have to go down to a load chart and find out your load factor. And what the UAV or UAS system is really actually experiencing would be 22.8 pounds. He also has an emphasis on emergency procedures and risk management. Radio communication procedures are covered on the test. Determining the performance of your small UAS are on the test. Psychological factors, aeronautical decisions for making proper judgments, airport operations, how close you can fly, maintenance and pre-flight procedures are also on the exam. So applicable regulations that are going to be to a commercial pilot for unmanned aircraft is in Title 14, Part 48 for registration and marking. And that's $5, and basically you get an FAA number that you have to have on your UAS. Also, all these applicable regulations apply, but the ones that are highlighted are heavy emphasis on the ones that are highlighted. So a little background on Title 14 of Code of Federal Regulations, Part 107. is when all these drones started coming on the market, the FAA wasn't really quite prepared on how to handle it. So in 2012, they passed the Modernization and Reform Act, and basically they sent out an NPRM and received 4,600 comments, and basically went over those comments and reviewed them, and then created Part 107 in a way to regulate what's going on with the drones. So here's kind of an interesting fact that once you already get past the Part 107 test and you're certified, you as the PIC or pilot in control are completely 100% responsible for the airworthiness of the craft. I believe that's something that's probably going to change as more commercial applications for delivering packages becomes more and more popular. Because with the Part 107, you're allowed to fly a craft up to 55 pounds, and honestly, I wouldn't even want 10 pounds falling on my head from 100 feet. So that's something that we may see change in the next couple of years. So here's the helpful link where you can find all the PDFs and the study guide and the advisory circulars that are going out. It's www.faa.gov/UAS/getting-started/fly-for-work. And there you'll find all your information and where to actually go and take these tests and how to apply for the 8071. So that's all I have for you guys today. Here's my contact info. If you have any other questions, feel free to email me.
All right, great. Thanks, Sam, and congratulations for your license there. Maybe you can talk to these guys I saw flying that drone over the high voltage lines.
Absolutely.
Okay, so now we are going to turn our attentions to the environmental aspect, and Mr. Corey Blackford is going to cover that for us. Hi, Corey.
So my name's Corey Blackford. I do a large amount of the environmental testing here at Washington Labs. Environmental testing for drones is a rather interesting aspect. There are no hard requirements like there would be for EMC and safety. A lot of this is more based on what the manufacturer really wants to do to make sure that they're building a good product. So in the first one, MIL Standard 810 is one of a number of various environmental test plans that can be used for drones and a large amount of other things. 810 is primarily used for U.S. in the military. It's also used for a lot of COPS, commercial off-the-shelf equipment, used by the military. There are some other standards, DO 160 and IEC 668 are also similar. It covers a lot of the different test procedures and the methodology, calibration requirements, that sort of thing, basically all the technical details required for it. There are a significant amount of details in 810G. Occasionally they get to the point of being a little too in-depth, actually. There's some technical guidance for tailoring parameters. 810G Change 1 is the newest version that requires tailoring, which is based on some of those guidelines and guidance given in 810. It's a departure from just straight 810 where tailoring wasn't strictly necessary, and we'll get into that a little bit later. It also goes into the appendices have all that exceptionally detailed information, definitions of the test parameters and durations, climactic conditions for worldwide applications, and some loose guidance on pass-fail criteria, and all this really links back to that tailoring requirement in Change 1. So this is a list of all the tests in 810G. There are a number that are significantly more often tested and used than others. Some of the things like rail impact, it actually requires you to have a train yard. Things have to be mounted on trains to be tested. Not so much applicable to drones, but there are a couple in here that that are applicable and some that may seem to be but aren't particularly. So this list starts off with some of the different tests that can be done. Altitude is ostensibly the most likely. Drones fly and altitude is related to height above the ground. Realistically, though, this doesn't make much of a difference. You've got some changes between, say, if you're flying in Denver, Colorado, or New Orleans, but drones, non-commercial drones like this sort of thing, really don't go high enough to run into problems like that. Most altitude testing starts at about 15,000 feet and goes up, typically for civilian stuff, up to about 60,000 feet. That's really not an area that drones really see. There are a couple interesting bits you can look at in that way. Lift versus altitude, as you go up, your air density decreases. That also has some effect on temperature and humidity, but not so much here. Dispersion of heat at altitude, which is typically what kills things at altitude, is your atmospheric density goes down. You lose the ability to convectively cool. Everything is conductive. In small things like stepper motors, this can be very bad. That's really the limit of altitude for drones. They just simply don't get high enough for it to be a problem. Low and high temperature, it's pretty relevant. You run into some things like operational parameters for things like your stepper motors, your controllers, your PCBs, all your RF equipment, that sort of thing. Battery stability is a big one for all the equipment running on lithium batteries. There's some pretty stringent temperature requirements that those can run into. Temperature shock is another one that is semi-related to high and low. It's essentially going from low to high or high to low temperature quickly. Not so much an issue with the drones themselves. One part this comes into play really is with the optics. If you have a drone, say, in your back seat in the summer and you've got your AC cranked so it's nice and cool in your car, but it's very hot and humid outside, you take your drone out and the optics on your drone fog up and you can't see anything. This is it depends on how you're flying and what you're doing it for, but that's pretty much the limit of temperature shock there. Humidity is also similar. You can have quick increases in humidity can cause condensation in some areas, mostly problems with optics. It can cause issues with electronics, but typically at lower voltages, it's not such a big deal. Although with lithium batteries, if those don't have short protection, that can get to be pretty ugly. But really, the main problem with humidity goes back to the same as temperature shock, optical problems, and that goes back to the quality of the optics used on the drone. Next, sand and dust. If you're at the beach and you're flying drones, they're going to get sandy. If you are outside and the pollen count is high, they're going to get dusty. This is one thing that a lot of people may not think initially applies to drones, because when you think of sand and dust, they can maybe something operating in the Middle East, somewhere like that. But when you stop and think about how people use these things, it tends to be a lot bigger problem, especially if they're not cleaned off properly, that sort of thing. They get in, they can foul motors, they can foul, again, optics, reduce reliability. There's a lot of stuff, and a lot of the effects of sand and dust can be cumulative also. So that's one place to look at. Immersion in rain. This one gets into primarily how manufacturers think their products are going to be used versus how they're actually used. Drones have kind of jumped up out of really nowhere rather quickly. So people are using them for all kinds of strange things. Realtors use them to take aerial photos and flyovers of property they're selling. Storm chasers in the Midwest use them quite often to cover things like flooding, severe storms, that sort of thing. People are going to be, at the beach. People are going to be flying these where it's not particularly expected, when it's raining, that sort of thing. So you get into looking at issues with light rain, severe rain. You're not going to expect someone to fly this in a thunderstorm, but they might. The shock and vibration really comes into transportation of the drone and that sort of thing. Whether you have just a soft backpack, whether you have, like shown here, a hard Pelican or Hardage style case, really how the drone reacts to testing that sort of environment, whether parts come loose, whether screws come loose, whether your controls stop working, that sort of thing. Operational vibration really isn't a major concern unless something is seriously out of balance, and if that's the case, the drone's probably not going to fly. It's going to be a self-correcting problem. But it also covers landing and crashes, which tends to be, at least from what I've seen, one of the places that people struggle with drones. So you may have hard landings. You can get back into designing for that, legs that are designed to flex and absorb some impact, cages around the propellers so that they don't hit things when they crash or that sort of thing. Then you get into confined environments, which is most commonly temperature and vibration. This isn't significantly applicable. You can look at some things like transportation, when these are actually being shipped out, either directly shipped from the manufacturer to the end user, or when they're being shipped from the manufacturer to a retailer, what the packaging is like, whether they are kind of on a unitized pallet in boxes, whether they're shipped individually. When that happens, these are in the real world, so if it's shipped during the winter, the truck's going to be cold. If it's shipped during the summer, the trucks they're in might be 130, 140 degrees Fahrenheit. So that is not how temperature and humidity and temperature and vibration and combined environments typically works for mill standard testing, but that is, I think, the most applicable part of that particular test for drones. So this is one I'm going to have to switch to, see if I can make this work, to pass-fail criteria. So this is a video that was taken, and it shows some testing going on. And the question for this, with your pass-fail criteria on how you decide what passes or what fails, is this to test a failure? Is it a pass? Without really setting your pass-fail criteria before you start testing, this test could have been a horrible failure, or it could have been an unmitigated success. It could have been a success if we're looking for prototyping. Did any of the units inside come loose? Did any of the units collapse? This is where you really need to define your pass-fail criteria before you start testing. This is where a significant number of manufacturers actually have issues when they come into the lab to start testing. They haven't decided what is a pass or what is a fail, or they want to decide that while the test is ongoing. This occasionally works out. Typically, it results in schedule holdups, in discontinuity between the lab and the manufacturer on what is actually a pass and what is actually a fail, that sort of thing. This is a primary problem typically when testing, is the lack of defined pass-fail criteria when the project starts. 810 has some leeway in what's defined as a pass-fail in some tests. Other tests are, I wouldn't say hard requirements, but there are some more less leniency. In other tests, it's really up to the manufacturer or whoever is testing to decide what passes or fails. Go back to...
Yeah, just stop sharing your screen.
Yeah, Christine, if you could, sorry. See if I can stop this. Yep, okay. So the last one here in summary is for testing, for determining tests, for determining conditions, for determining all the details that go into tests. Remember that products are used in the real world. What an engineer at his desk comes up with looking in 810G is saying, this is what we need to test because this is what we think is going to happen. End users are always going to exceed those expectations rather spectacularly. It's why product safety testing exists, because people use things in ways they don't think. The manufacturers don't think they're going to be used. So that really needs to drive, not necessarily drive what tests are done and what conditions are done, but it's one thing that needs to be, some attention needs to be paid to make sure that you don't have a large number of passes in the lab, but then when things are actually fielded, you run into large amounts of failures. And this comes into the next one, determining your test goals. Are you looking at prototyping? Are you looking at reliability and warranty mitigation? This typically that we see is determined by price point. If you go out and buy a $1,500 drone, your expectation is that while the warranty may be very good, you really don't want to have to use it. And that's where testing can help significantly. You can look at HALT testing, which is highly accelerated lifetime testing, which gives you a very condensed high-level test to give you an idea and an expectation of how long the products are going to last. It's not always bomb-proof, but it does work pretty well. There's other stuff. If you're testing, a $30 drone, just a very inexpensive one marketed towards kids, you might not want to do as much testing just to mitigate some of the cost. There's this is another area where you really need to determine what your goals are. If it's prototyping, the closer you can get towards what your end unit is will give you better results. We see a lot of things come in where they're 3D printed and they fail horribly as soon as we start testing, but this isn't necessarily realistic because while the chassis might fail, the components didn't. But that's because the chassis isn't remotely what's going to be filled into the real world. So the testing goals really come back to what your goal is, what stage your product is in, and how much you want to spend. Large test programs can get to be very expensive. The standard you pick also will dictate the tailoring. 810G Change 1 requires tailoring. Some of the other ones like IEC 668 seems like there's very little tailoring available in that particular standard. DO-160 allows some more leeway, and there's some other more specialized standards, but it really is going to, part of your test goals, this is also going to play into that. If you're selling something that you expect to have a long life cycle, it may mitigate, or it may make the test costs more difficult to bear because you may be selling less units, possibly offset by a higher initial price. But it comes back to the same as before, your test goals, what you want to do with it. The test sequence considerations, something that typically not a lot of attention is paid to. There's really two schools of thought, two ideas on that, whether to do the most severe testing first or to do the most severe testing last. Then this comes back to prototyping, whether you're testing a prototype unit or an end unit, whether you want to see cumulative effects, whether you want to see what each individual test does to the unit. That can be driven by the amount of units available to test. Scheduling for testing, there's a lot of things that can drive that. Ignoring most severe to least severe, one way to look at it is to do test first. It may affect test later. Temperature and humidity testing is a great place to start at it first before vibration and shock testing, because mold stress relief, that sort of thing, especially if you've got particularly high and low maximum temperature, can significantly affect what happens during shock and vibe and impact testing versus testing a unit that is fresh out of the box and hasn't had anything done to it. And again, determine your pass-fail criteria before testing. If you're on prototyping, are you looking for a hard fail to just to completely stop? Do you want it to still work? Is there a user reset? If the user can reset that, does that count as a pass or a fail? There's a significant amount of things there to really stop and look at. And your pass-fail criteria, you should spend as much time looking at that and determining what is going to count as a pass, what is going to count as a fail, as you do determining the particular test and details of those tests to be done, because it's just as important as those tests. If you run a test and you can't really say whether the unit passed or failed, it had some issues, maybe it didn't work, but after it was taken off and some stuff was put back together, it did. That can really complicate test plans. That's pretty much all I have for the environmental testing. It tends to be a lot more broad than some of the EMC and product safety and FCC requirements in regards to drones themselves. Environmental is a lot of things can be tested with environmental testing. It's very broadly applicable. For drones that I know of, there are no hard requirements for them. These would be, unless they're based on end user, if that company has any particular requirements. But that's pretty much it. If you have any questions, you can always email me, and I'll turn this back over to Christina.
Awesome. Thanks, Corey. Also, thanks to Steve, Elmer, and Sam for your contributions as well. I know that we said that we would put questions to email responses, but I figure since we have a few minutes, we did get a couple of questions in here about batteries and so forth, if that's okay with the panel. I'm going to go ahead and ask a couple of these questions that came in. One in particular, for batteries, I guess this is directed toward you, Elmer, for safety. What requirements exist for protection circuitry? They've seen many drones or quadricopters that are just using hobby battery packs with no protection.
Christina, let me go grab Elmer. He's actually in the lab right now covering one of the tests I was at. So let me go grab him and bring him back so we can answer some of that stuff.
I can try to field that if you'd like.
Okay. Yeah.
The battery packs, the hobby battery packs, may have protection. Once a package system is there, it has some marketing requirements for safety. So if it's usually in the market, there is a certain amount of safety implications by it being fielded, especially when we assemble packs from the cells that are sold with their inherent safety. Especially in the lithium world, there's a lot of shipping requirements, etc. And we also know that batteries, especially the lithium things, if they put on recharge when it's below freezing, these can be quite explosive. So several things come into being. So hobby batteries are not necessarily so benign, and assembled packages, the package that would fit the drone by the manufacturer. But remember, don't assemble your own pack from cells without analyzing the requirements for the integration of a pack, because suddenly you've assembled something that has higher voltage, higher current capability, depending on how you've arranged them, more longevity, etc. So by that token, if you self-inflict a battery thing, you need to get the approvals for a battery requirement. In the U.S., that comes under UL, and in Europe, it's under the IEC-EN documents, and many countries fall to that IEC, the International Electrotechnic Group. Hopefully that addressed that question.
Okay. There's another one about battery testing. What sort of battery testing cell and pack is required, and can Washington Laboratories perform the testing?
We can do some of the testing. We usually put it into a battery specialty thing. There are battery tests that are involved in product approval that we do execute, and we analyze fault conditions related to the battery integration instead of the individual cell. Most of our products have an end use that incorporate a battery, and we rely on the certification of the battery and any conditions of acceptability for the battery that's involved in integration. We make sure the integration accomplishes that. But generally in the distinct battery, we defer to the specialists in that particular area for an individual battery item itself. Okay.
All right. Here's a question about the FAA. Do you see the FAA coming out with a set of functional requirements in relation to redundant systems or software documentation and so forth? I guess that's for you, Sam. Any comments at this time?
Yeah, I could see them coming out with regulations on that. As of right now, it's all about the PIC, the pilot in control, taking most of the responsibility of actually evaluating and making sure everything's safe and whatnot. So I could see that happening probably next year or so.
All right. See, I got just a couple more questions. Here's one about if the drone is intended for operation by ages 18 and older, do you still need to perform the toy/safety testing? I'm going to assume that one is for...
Could you repeat that, Christina?
Sure. If the drone is intended for operation by adults ages 18 and over, do you still need to perform toy or safety testing?
Basically, the safety rules are in place for electrical and general product safety. In the U.S., the UL rules that are executed by the various nationally recognized system laboratories are involved there. General product safety should be there to where a child doesn't get their finger into the propeller and get damaged, especially the non-commercial. But in the commercial world, it still comes into being, and it could default into a hazard-based kind of system, where if there are adequate rules and the operator is skilled, there may be some exceptions. But generally speaking, the safety rules are there as a manufacturer to mitigate liability concerns. You can ship your product out there, and if you've not used due diligence in executing safety and there was an injury, then your liability says you weren't executing due diligence, and the litigation matters tend to get much higher awards, etc. Also, your insurers are going to ask that you conduct a certain amount of safety to see that your liability issues are somewhat controlled. You remain liable, but you are using due diligence, and it may say you may get a jury in your favor if you've executed properly. So generally speaking, safety should be applied. The depth of it may or may not be so harsh. And for the European rules, it's mandatory. You must do the safety to comply with the radio equipment directive, just because the radio is there, no matter what voltage you're operating. So several things demand it. Other things should be exercised in due diligence. You don't want to lose your company because of a minor issue that you just didn't do due diligence.
Okay. I guess we can let's take one more question here. How are drones inhibited from flying near protected airspace?
Well, some of the models actually have a built-in failsafe in which it uses the GPS to know exactly where it is, and if it's within about a mile or so of the airport or protected airspace, it will not fly. But for the smaller models, like the toy store models, this is an issue because they don't have GPS systems and they can potentially fly near a protected airspace. So it really depends on the manufacturer and the quality of the drone, etc. Hope that helps.
Can we use those small ones in the space as skeet?
That's probably what will happen to them if they are over an MOA.
So, Steve, with your comment about the toy standard, was that meaning yes or no for needing to comply with toy standards?
If the particular model is classified as a toy, it would come into being under the toy rules. It's a matter of the cost, application size, and the marketing behind it. A toy can be several $1,000s for some people, but generally speaking, it's more commercial there. So the toy things have a kind of a consideration in how you market it in your application. If you can identify that your marketing things are directed towards a toy type thing or children, then the toy rules would come into being as additive to the other things that may be applicable.
All right. Well, I hope that does answer the question. It's all in the semantics and the marketing, I guess. Okay, well, thanks again to all of our panelists. If anyone else has any questions about any of the material that we've covered in today's webinar, please contact us using academy@wll.com, or you can email one of the presenters from today, and someone will get back to you with some information. Before we go, I'm going to go ahead and go over some information about upcoming training from Washington Labs Academy. You can link to us at wll.com/us/academy, and you'll find information on all of our webinars and resident courses. Here's a quick look at what's upcoming. We have next week, we have a product safety webinar, session 4, covering thermal and fire safety on Tuesday, May the 9th at 11 a.m. Eastern. The wireless technology webinar series continues with broadband devices on May the 10th. Class is held on Wednesdays at 11 a.m. Eastern through the end of May. The last offering of our EMC MIL 461 hands-on course will start May 16th through the 19th at our Gaithersburg lab. Our EMC MIL 461G webinar series completed in early February, and we have recorded playbacks available. The environmental MIL standard 810G webinar series is currently in development. Battery technology by Battery University. That's back due to popular demand. It was a 4-part webinar series. It's running again in September. There's a couple of events happening elsewhere in the testing universe. Next week is the 2017 IEEE Symposium on Product Safety Compliance Engineering. That kicks off May the 8th in San Jose, California. And in Washington, D.C., the week of August 7th is the IEEE EMC Signal and Power Integrity Symposium. I believe, if you plan to attend, I believe Steve Ferguson will be there. Is that right, Steve? Feel free to stop by.
Yes, I got all kinds of things. I'd like to hear from everybody. Say hello to me when I'm around the area. I'll be mostly in the IEEE aisle, I believe, is where I'll hang out a lot.
I'll make sure you stop by and say hello if you're going to go to that, folks. All webinars, recordings, and resident courses are available for purchase from the website. The website webinars are available as multi-part series events, so you can pick out any one of the class topics to attend, sign up for a whole series, and receive a 15% discount. And, of course, we'd like to hear from everyone with suggestions on future topics we can present to you. We also provide customized training at your place or ours. So be sure to visit our webpage to check out the latest on the training course topics and dates. And that's going to conclude today's webinar. Many thanks to our presenters for their time and contributions. And on behalf of myself and the Washington Labs Academy, I'd like to thank everyone for their attendance. At this point, I will go ahead and end the event. I hope everyone has a good day. Thanks a lot. Bye-bye.